everyone, you have done with the subtopic differentiation before. Now we move to the next subtopic in this calculus, which is integration. In this subtopic, we will learn on the introduction to the integration, a few techniques that we can use to do an integration, and also a few rules and properties of integration. So let's explore with me integration. So everyone, let's start to see what is actually an integration process. So integration is actually the reverse process of the differentiation process, or we call as antiderivative. If before this, we have learned on how to do a process of differentiation to the equation of y or function of fx. Let's say we have an equation, for example, y equal to 3x to the power of 3. Okay, if let's say we want to do a process of differentiation, or we want to find what is the derivative of the equation y with respect to x, the symbol of this process will be dy dx, where dy dx means the derivative of y or the differentiation of y with respect to x. So we have two step technique that we learned before, which is the first one, we need to bring the power to the front and multiply with whatever coefficient that you have in front. So 3 multiplied by 3, you will get 9 x. And the second step is you need to reduce the power to by 1. So from 3, you left only 2. So now your equation y have its derivative dy dx. So what is actually the process of integration? The process of integration is known as the antiderivative process, where process of integration will return back your equation in derivative form into its original equation here. Is if from equation y to dy dx, we are doing the process of differentiation. Okay, from dy dx to return back into equation of y, we are doing the process of integration. That's why the process of integration is called as antiderivative process or antiderivative technique, because it will return back your differential equation, the equation that have undergo process of differentiation into its original form in the form of y equal to certain variable. Okay, so if you see here, let's say you have an equation 2x x squared, sorry. So if you have an equation x squared, the first place, okay, you have an equation x squared, the first place. If you are doing the process of differentiation, or you find the derivative of x squared, what will you do is you will bring 2 in front, multiply by 1. So 2 multiplied by 1, you will get 2. Okay, and the power of x will be minus by 1. So 2 minus 1, you have x to the power of 1. That's why from x squared, after the process of differentiation, you will get 2x. Now, we want to return back 2x to its original equation. So what we need to do is we need to do a process of integration. Okay, so the symbol of process of integration is the curly bracket in front. Okay, it means that the integration of the function 2x with respect to x. Okay, what do you mean with respect to x? We will integrate the variable x that you have in your equation. Okay, so if before this, to do a process of differentiation, we need to do 2 steps. The first step is you multiply, and the second step is you minus with 1. Okay, you have ax to the power of n. So the first step that you do if you want to do a process of differentiation is you will bring n to the front and you multiply with the coefficient, and the power n here you will be minus by 1. So it involves two operation, which is multiply and minus. Okay, and for the process of integration, it also involves two operation, but it's opposite than differentiation process. If in differentiation process, the process is multiply and minus, so in integration process, you also have two steps which involve division and plus. Okay, multiply, opposite multiply is divide, opposite minus is plus. Okay, so let's say now you want to integrate the function of 2x with respect to x. What you will get is, the first step is you need to plus the power of x by 1. If derivative just now you minus 1, now integration you need to plus. Plus the power first. So you have 2x here, right? So you have 2x. The power is 1, plus with 1 you will get 2. First step. And the second step is you need to divide. If in derivative you have used the operation of multiplication, now in integration you will use the operation of division. So you need to divide. Divide by what? You need to divide by the new power here, which is 2. Okay, so 2 in the numerator can be cancelled out with 2 in the denominator. So what you get in return is x to the power of 2, which is the initial one, the original equation. So actually, the process of integration will help you to return back your derivative into its original equation. That's why it's called as an antiderivative process, because it's opposite the process of differentiation. Integration and differentiation is an opposite process. If in differentiation is involved two steps with multiplication and minus operation, in integration is also involve two steps, but the operation that involved is division and summation, addition. Okay, where the first step you need to plus 1 your power of x, and the second step you need to divide by the new power. Okay, so let's say we have another example here. Okay, we have another example here. Okay, so we want to see how the process of integration can return back the original into original equation. Let's say we have y equal to 5x to the power of 4. You want to do a process of differentiation, so what you will get is dy dx, where dy dx means the derivative of y with respect to x. So what you will do to do a differentiation process, the first one, you will bring your power to the front and multiply. So 4 multiplied by 5, you will get 20x. The second step is you need to minus your power by 1. So 4 minus 1 is equal to 3. Now we want to see either it's true, process of integration can bring back your original equation 5x to the power of 4. So what we need to do is, we need to do a process of integration to the function of 20x to the power of 3 with respect to x. Okay, so now we want to do a process of integration to the function 20x to the power of 3 with respect to x. So remember, you have two steps. The first step is you need to plus the power of x by 1. So you have 20x. Now the power of x become 4. Okay. And the second step is divide. So what you need to do is you need to divide by the new power. The new power here is 4. Right? So 20 you can divide by 4, you will get 5x x to the power of 4. So you get back the original equation here. So this is what process of integration give you. It will give you the original equation after you have done the differentiation process. So you need to remember that integration process is the antiderivative process, where it is opposite with the differentiation process that we learned before. Okay, how if we have a function of x where fx equal to 7x to the power of 3 plus 5. Now we want to do a process of differentiation that we learned before, okay, to find the derivative of the function fx, where the notation of the derivative of the function fx is f prime x. Okay, so you want to do a process of differentiation. You need to remember it's involved two steps. The first step is you need to multiply the power with the coefficient in front. So now you multiply 3 with 7, you will have 21x. The power minus by 1, so you have 2. And you need to always remember every time you are differentiate 5, which is constant, you will get the answer equal to 0. Why? I have explained in the previous video. Actually, behind every constant, you also have a variable x. But the power of your variable is equal to 0. Anything, any variable, any term with the power 0, the value is equal to 1. Okay, that's why we are not writing 1 behind your coefficient or behind your constant. So you actually cannot see x to the power of 0 behind every constant, but the concept is you have x to the power of 0. So when you do a process of differentiation, you multiply 0 with 5, you will get 0x to the power of negative 1. And anything when multiply with 0, the answer will be equal to 0. This is the reason behind why every derivative of a constant is equal to 0. So if you differentiate your function of fx here, what you will get is only 21x to the power of 2. Okay, so if you want to return back your f prime x into its original equation here, which is fx, what you need to do is you need to do a process of antiderivative, which is integration process. So what you need to do is you need to integrate 21x to the power of 2 with respect to x. What do you mean by with respect to x? You only will integrate term x, variable x. So you only will do operation on x. Okay, so what operation you want to do? When integration is involved two operation, which is plus and divide. So what you want to plus? The power of your x will be plus by 1. So you have 21x to the power of 3. And the second step is you need to divide by the new power, which is 3. Okay, so 21, you divide by 3, what you will get in return is 7x to the power of 3. So you only get this part, 7x to the power of 3, but you didn't get the constant behind. Because there is nothing behind here. Actually, you have something behind here, which is 0. So, because of every derivative of a constant is equal to 0, so every time we do a process of integration, we need to put plus c at the back. Because you might have any constant behind your equation. Okay, for example, if I have equation y equal to 20x to the power of 2 plus 100. Okay, when you do a process of differentiation, you will get dy dx. Okay, you differentiate this one. 2 multiplied by 20 is 40 x. 2 minus 1 is 1, so 40x to the power of 1 plus you differentiate constant, you always get equal to 0. So what you will get actually is dy dx is equal to 40x. So every time you want to return this equation into its original equation, okay, because you have done a process of differentiation here, so if you want to return back it to y, what you need to do is you need to integrate your 40x with respect to x. So when you integrate your 40x with respect to x, what you will get in return is, the first step, you need to plus your power with 1. So 40x, here you have power 1, it will become power 2. And the second step, you need to divide by 2. Okay, so what you will get here is 40 divided by 2 is equal to 20x to the power of 2. So what you get only the first term here. You didn't get 100 because 100 is a constant. That's why every time we do a process of integration, we need to put plus c at the back of every equation that we get. Let's see these two examples here. We want to integrate 4x to the power of 3 plus 5x minus 2 divided by x squared with respect to x. You cannot integrate when you have a fraction. So you need to solve the fraction first. So what we can do here is, because all equation or all terms share the same denominator, so what you can do is you can give each of them, okay, the same denominator. Okay, so you can transform this integration into 4x to the power of 3 divided by x squared plus the second term 5x divided by x squared minus the third term 2 divided by x squared with respect to x. So what we need to do next is we need to simplify first so that we will not have any denominator before we can do a process of integration. Okay, so what you can do is, if you see the first term here, you have x to the power of 3 on the numerator, and you have x to the power of 2 in the denominator. So you can cancel out 2. So 3, it only left with 1x, and denominator is already eliminated. Okay, and then the second term, you have 1x in the numerator on top, and you have x to the power of 2, means you have 2x in the denominator at the bottom. So what you can do is you can eliminate 1x, okay, the minimum one. So you only can eliminate 1x, so the x in the numerator will be eliminated, and x in the numerator from 2, it become only 1 because you already eliminate 1x. Okay, and then for the third term, you cannot eliminate any x because on the numerator, you doesn't have any x. So how we want to solve, because we still have the denominator. So you need to remember that we can bring our variable from denominator up to the numerator. What will happen is the sign of the power will be opposite the current sign. If now you have positive sign, when you change the position, it will become negative. So let's see. Okay, so now we have integration of the first term. You already eliminated everything in the denominator, so you only left with 4 and 1x plus, in the second term, you still have x to the power of 1 in the denominator. So x to the power of 1, if you want to bring on top, okay, you want to change the position, the power will become opposite sign. So if now the power is x to the power of 1, now it will become x to the power of negative 1. Okay, it will change the sign of the power for your variable. And for the third term, you have x to the power of 2 in the denominator. So now you want to change the position of your variable. You want to bring it on top. So what will happen when you change the position? The power will be opposite sign. So if you have now x to the power of 2, now you will have 2x to the power of negative 2 dx. Okay, so now you can do a process of integration. Remember, we have two steps to do an integration process. The first step is you need to plus 1 your current power. Okay, and the second step is you need to divide your term with the new power. So you see your first term here. Okay, your current power is 1. You cannot see 1. Okay, we are not writing any 1. Okay, so you cannot see 1 here. So you have power 1. So the first step, you need to add 1 to your power. So now your power become 4x to the power of 2. First step. And the second step, you need to divide with the new power, which is 2. Okay, plus, okay, you have 5x. So now your power is negative 1. The first step of integration, you need to plus 1. Negative 1 plus 1 is equal to 0. Okay, and divide it by the new power, which is 0. Okay, minus with 2x. Okay, you have your current power is negative 2. So you need to plus with 1. So negative 2 plus with 1 is equal to negative 1. So you have your new power here. And the second step, you need to divide by the new power. The new power is negative 1. And don't forget that every time you are doing the process of integration, you will get plus c at the back of your equation. Alright, now we see one by one which one we can simplify. So 4 divided by 2, you will get 2x to the power of 2 plus. So you see here, okay, when you have term divide with 0 is actually infinity, which is cannot be defined. Okay, so when you have infinity, okay, anything that divide with 0, you actually have an infinity. So we just ignore it for this case. Okay, we just ignore it for this case because you divide your equation with 0 is actually infinity. Okay, we just ignore it. Okay, so next term is, the third term is minus. Okay, you see you have minus here. You also have minus here. So minus and minus will become plus. Okay, 2 divided by 1, you still have 2x to the power of negative 1 plus c. So this one is your equation after process of integration. You can leave your answer like this, or you can choose to bring back your x. Because you see here, your x is in the negative power. So what you can do is you can change the position of your x so that the power will become positive. So you want to change where? You will bring back your x to the denominator. So what you will get is 2x to the power of 2 plus 2 divided by x to the power of 1. Now, the power will change its sign, opposite sign. If now is negative, when you change the position of x to the denominator, the power will be positive. And we're not writing any 1. Okay, we are not writing 1. So we just left it to become x. Okay, and then you will have plus c. So this is what you get after the process of integration. Okay, so let's see one more equation here. You want to integrate 5 square root of x plus 3x to the power of 4 plus 7 with respect to x. Okay, class. If the question before is in the fraction form, where I told you we cannot integrate fraction, we need to do some changes, is similar to the equation that involves square root. You cannot integrate or you cannot differentiate square root. So square root need to be changed into power. So how can you change your x square root 2 into power? Okay, it will become x to the power of a over b, where a is the value of your power of x, b is the value of your root. For example, now you have x to the power of 1, square root 2. Okay, for example, now you have x to the power of 1, square root 2. So your a is 1, your b is 2. So when you want to change it into power, it will become x to the power of 1 over 2. Okay, x to the power of 1 over 2. For example, if you have x to the power of 3 square root 4. If you cannot see any number here, okay, any number outside the square root means it's square root 2. The least square root value is 2. Okay, so for example, this one is x to the power of 3 square root 4, because you can see here is 4, this one is 3, this one is a, this one is b. So when you want to write this one in the form of power, it will become x to the power of 3 over 4. This is how you change the root into power form. And every time you want to do a process of differentiation and a process of integration, you cannot do these two processes with root. You need to change first the root to become a power. So now we want to change our root to become a power so that we can use or we can do a process of integration. Okay, so now you have x to the power of to the square root 2. So you want to change, so you have integration of 5 x to the power of 1 over 2. We change square root 2 into power, it become 1 over 2, plus 3x to the power of 4 plus 7 with respect to x. So now you can continue with the integration process. Okay, the first step is to plus your power with 1. So you have your current power is half here. So you plus with 1, half plus with 1, you will get 3 over 2. So you write 5x to the power of 3 over 2, the new power, first step. And the second step, you need to divide by the new power, which is 3 over 2. So divide by 3 over 2. Okay, so plus, okay, this one, you have x to the power of 4. So what you will get is 3x to the power of 5 divide by the new power, which is 5, plus, okay, how can you do this one? You cannot see any x. Remember, I told you if you have constant, actually at the back of every constant you have x, but the power of x is equal to 0. That's why you cannot see, because x to the power of 0 is equal to 1. So when you have constant, you still do the same process, where you imagine that you have x to the power of 0 behind every constant, and you do the same process, which is the power you plus with 1. So now you have 7x to the power of 1 divide by the new power 1. And don't forget that every time you are doing the process of integration, at the back you need to put plus c every time. Okay, now is the method of simplify our equation. We have done with the process of integration actually. So now we just want to simplify our equation. Okay, so how can you simplify this one? You have 5 divided by 3 over 2. So when you have the number, the constant, divide by fraction, you just need to change divide into multiply by 30 turn this one upside down. 3 over 2 become 2 over 3. So it will be 5 multiplied by 2 over 3 x to the power of 3 over 2 that you have here. Okay, plus with, so this one you just copy 3x to the power of 5 divided by 5. So 7 divided by 1, you still have 7x plus c. Okay, so you just need to simplify this one, multiply. 5 multiplied by 2, you will get 10 over 3x to the power of 3 over 2 plus 3 over 5x to the power of 5 plus 7x plus c. So this one is the answer for your integration of this equation. So the important things is the integration process also involves 2 steps, where the first step is you need to add your power with 1, and the second step is you need to divide everything with the new power. But what is the important thing that you need to remember is each and every time you do a process of integration, you need to put plus c at the back of your equation. The reason have been explained before because it might have a constant actually in the original equation before we have to a process of differentiation. Okay, so we will continue with the next topics in the next video.